Okay guys, now we are going to see that how we are going to name a complex. Okay, so there are certain set of procedures what we have to follow whenever you are writing a complex name. So let us deal now one by one. So first IUPAC nomenclature, what does it says is whenever you're writing a complex, you have to remember in your mind that, for simple example I'm giving you, so whenever we are writing as NaCl, so of course the first part will be your cation, the second part will be your chloride. Whichever compound you can take. For example, if you're taking is your calcium chloride, it will be your Ca2 plus 2Cl minus. That is, first any compound whenever we are choosing or whenever we are writing, first is written as cation, then it is written as an anion. In the same way, whenever we are choosing a complex, it will be in the same format. Any complex they may have given you, the first part will be a cation, the second part will be your anion. So whenever you are now naming a complex, you have to keep in your mind, whenever you are choosing a complex, it will be having two parts, a counter ion and a coordination sphere. Now we are going to see how to name that coordination sphere, that is the entity which will be present within the bracket. So remember, while naming a complex ion, first you have to name the ligand, okay? Then you have to name the central metal atom or the ion together with the oxidation state in Roman numerals within the parenthesis that we are going to see in the example. Just you have to keep in your mind what is your first step is. Any complex they may have given you, you have to first judge that first part will be your cation, second part will be your anion, and in that coordination sphere within that square bracket, first you have to name the ligand, then you have to name your central metal atom or the ion along with its oxidation state within the parenthesis, that is within the bracket in a Roman numerals. The second point, what does it says? If the complex contains different ligands, their name should be arranged in an alphabetical order. That is, if you are having chloride is also there, bromide is also there. Since chloride may C, whereas in bromide it is B. So alphabetical order may what comes first? B comes first. So you have to first name as bromide, you have to first name bromide, then you have to go with that of chloride. Similarly, the extends it, what does it say? If more than one unidentate ligands are present, then you have to use the Greek prefixes as di, tri, tetra, etc. should be used to indicate their number. But in case if you are having a bidentate ligands and in ligand name itself is containing some di, tri or like that, we will be using to indicate their number by other Greek prefixes as bis, 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 tris, tetrakis, pentakis, etc. Okay. So in case of a ligands, what they are saying that whenever you are naming the ligands, if there are more than one type of a ligands, unidentate ligands, you have to arrange them in an alphabetical order. If there are more than one unidentate ligands, then you have to use the Greek prefixes as di, tri, tetra. If the name itself, for example, ethylene diamine, which is a bidentate ligand, the name itself you are having a di. When such ligands you are having, you have to use the Greek prefixes as bis, which indicates that en twice. So this twice will be represented over here. Tris means thrice, like that. So in the third point, they are saying that, so the name of the anionic ligand, please mention over here, the name of the anionic ligand ends with O. And the name of the cationic ligands ends with IUM. And the name of the neutral ligands is written as such. Let us go with it. Anionic ligands, my first example is that of your cyanide. We know that cyanide. But cyanide, when we are writing it as wow, Cn minus. So which means what? It is an anionic ligand. So its name will end with cyano. That is ending with O. Similarly, Cl minus. So here also what is doing? We will be writing as chloride. Alva, chloride. So what happens over here? Chlorido, ending with O. Similarly, Br minus, anionic ligand, ends with bromido. Similarly, OH minus ends with hydroxo. So whenever you're naming the anionic ligands, its name ends with last alphabet will be your O. Similarly, when you're using your cationic ligands, for example, your NH4 plus, of course, it ends with ammonium, IUM. The last term will be ending with IUM. Similarly, if you go with your NO2 plus, you will be having as nitronium, IUM. Similarly, NO plus, you will be having as nitrosonium. Whereas the neutral ligands, there is no such tendency you have to follow. The names are ligands written as such. For example, if you are having CO, this is written as carbonyl. If you are having as NH3, it will be written as amine. Okay, if you are having H2O, it is written as aqua. Similarly, if you are having as NO can exist as also as a cationic ligand and also as a neutral ligand. Whenever it is acting as a neutral ligand, it is written as nitrosyl. So remember, so whenever you're writing for an anionic ligand, the name ends with O. Remember, with chlorine, chloride, chlorido, bromine, bromide, bromido, hydroxide, hydroxo. Similarly, when you're dealing with that of your cationic complexes, there is you're having an ammonium, nitronium, nitrosonium. Whereas in the neutral ligands, the names are written as such. Whenever it is a carbon monoxide, CO, carbonyl, NH3, amine, H2O, aqua, NO, which is a neutral part over here, which is called as nitrosyl. Remember, the next most important thing, whenever you are naming your anionic complex, the name of the central metal atom or ion ends with A. So before dealing with it, you have to first understand that what do you mean by anionic complex and a cationic complex. So as said earlier, so whenever we are writing a compound, first will be your cation and then will be your anion. Similarly, if I take an example, K4FeCN6. So what happens over here, you could just notice that here my potassium is what it is, a cation. Then this FeCN6 what? It is an anion. So this is forming an example of what? Anionic complex. Why? Because the complex, the coordination sphere FeCN6, when it is dissociated, is giving us 4-. So this is having an anion tendency. If I take another example over here, for example, if I choose as Cr, NH3 thrice, H2O thrice, then comes your Cl3. Of course, now this is your coordination sphere and this is your complex, this is your counter ion. So when I am choosing, what happens, so this will be your cation, this will be your anion. So when it dissociates, what it should give you? Cr, NH3 thrice, H2O thrice, 3 plus 3Cl-. So this will be called as what? Complex cation or cationic complex. The complex which is having a positive charge, that is called as what? Complex cation. The complex which is having an anionic charge, that is called as what? Anionic complex. Now once we have dealt with the difference, now we are going to see what is the nomenclature rule. Remember, whenever you are naming an anionic complex, the name of the central metal atom or the ion ends with 8. For example, is your iron, we get to ferrate, copper, we get to cuprate, platinum is platinate, nickel is nickelate, your palladium is palladate. Okay, so your lead is palladate, your silver is argentate, gold is aurate. Nothing much, you are adding at the last as ATE when it is having an anionic complex. But in the case of the cationic and the neutral complex, the name of the central atom or ion does not change. So first are the rules they are saying. So whenever you are naming your complex ion, first you have to name the ligand, then you have to name your central metal atom or the ion along with its oxidation state in the Roman numerals within the parenthesis. So when you are coming with respect to the ligands naming, of course they should be named in the alphabetical order. In case if you are having more than one ligands of the same kind, then you have to use the Greek prefixes as di, tri, like that. If the name itself is indicate having this di, tri, then you have to use the Greek prefix as bis, tris, tetrakis, etc. Remember, when you are naming the anionic ligands, the name of the ligand should end with O, whereas the cationic ligands would end with ium, and whereas neutral ligands, there will be no such changes. Remember, when you are naming the anionic complex, the name of the central metal atom ends with 8, whereas in cationic and neutral complex, such changes are not observed. Now let us take an example. So first example is Cr, which has been bonded with NH3 thrice, H2O thrice, Cl3. So let us have a quick revision of what we have done earlier. Of course, here you can just see that. So this is your coordination sphere, this is your counter ion, that is Cr, NH3 thrice, H2O thrice, which is enclosed within the square bracket is your coordination sphere, whereas your Cl is your counter ion. The next important thing is, what is coordination number? Of course, they are unidentate ligands. So there are 3 ammonia molecules, 3 water molecules, unidentate. So coordination number of chromium is 6. Coordination number of donor atoms, which is number of donor atoms of the ligands, which is binding your central metal atom or the ion. So the coordination number is 6. Now coming with respect to the nomenclature. So what does it says? So first we have to identify whether it is a complex cation or a complex anion. Since the complex means which is written within this square bracket. So this has been counted first. So whenever we are writing a first will be your cation, second will be your anion. Since it is in the cation category, of course this is a complex cation. So no need of changing the name of your central metal atom or the ion. So first we have to name your part, which is one. First you have to name your cationic part. How you are going to name? So first you have to name the ligands. So there are more than one ligands. Okay, so you have to put in an alphabetical order. Here ammonia is also a neutral ligand, and that of your water is also a neutral ligand. So how you are going to use? So tri, aqua, yes, tri, amine. In both the cases it is AA, so you can use any of the words, no problem. Tri-aqua, triamine. So ligands I have named. Then I have to name your central metal atom or the ion. That is, you are going to name it as chromium. Okay, I have first named my ligand, then I have named my central metal atom or the ion. Now I have to name its oxidation number. Remember, oxidation number, not the coordination number. So how are you going to calculate now? I want the oxidation number of my chromium over here. So let me take my chromium as X. Yes. So basically ammonia is a neutral molecule which is having no charge. So that will be 0. Similar, my water is also a neutral over here, which is also a 0. Okay. And which is binded with my chloride over here, that is having -3. Since each chlorine will be a negative charge. So overall is a neutral complex not having any charge. So overall should be equals to 0. So X will be equals to +3. So now the oxidation state is written within the parenthesis in Roman numerals. So once you have written the complex part, now you have to write your counter ion. That is your anion. That is will be written as chloride. Chloride. Remember, it is a counter ion, so you should not consider it as a ligand now. It is outside the square bracket. So just you have to write it as chloride. So what is the name? Triaqua, triamine, chromium 3rd, chloride. Let's deal with one more thing now. K4, FeCN6. So of course now what has happened? Your complex part, your coordination ion. So your potassium is acting as your cation, and your complex part is acting as your anion. So this overall complex is an example of anionic complex. So remember. So first you have to name your cation. So what happens? Potassium. First we have named the cation. Now when naming your coordination part, you have to name first your ligands. That is potassium, hexacyano, because it is what? Anionic ligand, hexacyano. Okay, now you have to name your central metal atom or the ion. Since in the first example it was a complex cation, we have written the name of the metal as such. But now it is a complex anion, so name of the central metal atom or the ion ends with ATE, ferrate 2. So now we got the complex name as potassium hexacyanoferrate 2. You understand? Now let us take one more example over there. K3Cr C2O4 thrice. Okay, so of course this is a complex overall. This is your counter ion, this is your complex ion. So this is first comes your cation, second comes your anion. So of course this is an example of an anionic complex. Very much important because it depends the name of your central metal atom or the ion. So how are you going to write it now? Potassium. No need of identifying its number. Enough if you write there potassium. That's enough. So potassium. So now we are going to write it as, since oxalate, you have to remember it's a didentate ligand, but the name itself is not containing any di, tri or like that. So you can use this as tri. But it is an anionic ligand. So trioxalato. Trioxalato. Alva, trioxalato. Next you have to write your central metal atom, chromium. What is the coordination number? Just calculate it. So K3 means how much? Yeah, each potassium is having +1 charge, so we have to write it as 3 plus X. But this is a bidentate ligand, remember, so plus of each oxalate is having a charge of -2. There are such 3 oxalates, so overall is equals to 0. So what are you going to get? 3 plus X minus 6 is equals to 0. X is equals to +3. So here you are going to get as 3. You to understand? If the same thing if I am going to give you as FeCN6 4 minus. If this is the complex they have given you, of course by here itself you could just see that it is a complex anion. So first you have to name your ligand hexacyano because it is an anionic ligand. Then anionic complex may you have to name ends with 8 of your central metal atom, ferrate. What is the oxidation state? 6 minus, how are you going to calculate it? X minus 6, that is equals to -4. This was a neutral complex in the above cases, so we took it as overall is equals to 0. But here they are given as your ion. So here its overall is -4. So X is equals to +2. So remember, whenever they are giving you such an ion, the name ends with ion. So hexacyanoferrate 2 ion. Is that clear? Okay.